In this mini clip, we'll be discussing piecewise functions. While we answer this question together, you will be solving the similar problem on your own using the same technique. So given this function here, we are asked to find f of 1, f of 3, f of 5, and to finally sketch our function. So taking a closer look at our f of x, we will notice that it equals x squared if our x is less than or equal to 3. However, if our x is greater than 3, then it would equal 12 all over x minus 3. So let's begin by evaluating f of 1. This means that we are evaluating our function f when our x is equal to 1. So we need to find the restriction which satisfies our x when it is equal to 1. So we will notice when x is equal to 1, it is satisfied with this restriction because 1 is less than or equal to 3. As a result, we will be using this function, x squared, when evaluating f of 1. So since we know that 1 is less than or equal to 3, we will be using the function f of x is equal to x squared. Evaluating for f of 1, we're going to substitute 1 in for our x. So we have f of 1 is equal to 1 squared. So finally our answer, f of 1 is equal to 1 squared is simply 1. I want you to now solve for f of 1 in your question. Here's the answer you should have got. Now let's evaluate for f of 3. So we're evaluating our f function when our x is equal to 3. So if we look at our first restriction again, if x is equal to 3, we'll notice that 3 is less than or equal to 3. So this restriction satisfies our x when it is equal to 3. Our second restriction only deals with values of x that are greater than 3. This is why we want to use our first restriction. So again, we have that 3 is less than or equal to 3. So we're going to use our x squared function once again. So we have f of x is equal to x squared. Evaluating when x is equal to 3, we'll have f of 3. We're going to substitute our 3 into our x to get 3 squared. So our final answer for f of 3 will be 3 squared, which is equal to 9. I now want you to evaluate for f of 4 in your question. You should have found that f of 4 is equal to 16. Now we're going to evaluate for f of 5. So we're evaluating our function when our x is equal to 5. Our first restriction only deals with values of x that are less than or equal to 3. Since 5 is greater than 3, we cannot use this equation here. If we look at this restriction, if we have x is greater than 3, then we're going to use this function. Since 5 is indeed greater than 3, we want to use this function, 12 all over x minus 3. So again, we have 5 is greater than 3. So we're going to use our function f of x is equal to 12 all over x minus 3. Evaluating when x is equal to 5, we'll find that f of 5 is equal to 12. Now our x is equal to 5 minus 3. We're going to simplify our denominator to get 12 over 5 minus 3 will give us 2. So our final answer will be f of 5 is equal to 12 divided by 2, which is 6. I now want you to solve for f of 6 in your question. You should have found that f of 6 is equal to 8. The last part of our question asks us to sketch our piecewise function. So in order to do this, we need to draw our x and f of x axes. So let's look at our first function, x squared. We should all be familiar with this shape. It will produce a parabola that opens up and is centered at 0, 0. However, our function is only equal to x squared when our x is less than or equal to 3. So here we have our 3 on our x-axis. Here we will have negative 3. So our function will equal x squared only when x is equal to 3 or anything less than 3. That means from this point and anything less, our graph will be this parabola, x squared. So when x is equal to 3 and we plug this into our f of x function, 3 squared will give us the value 9. So here's 9 on our f of x axis. When x is equal to 3, this is the point that we will have. Now we have a parabola-like shape centered at 0, 0. So we're going to go up until this point, and we can't go any further because x is only less than or equal to 3. And now from here, we're going to go on with our shape in the opposite direction because x can be less than or equal to 3. And this will keep going as x becomes smaller and smaller. Now let's take a look at our second function. We have f of x is equal to 12 all over x minus 3. And we'll notice that we use this function when x is greater than 3. Since our x is in the denominator here, as our x gets larger, our denominator will also get larger. And 12 divided by a larger number, the entire value of this function will become smaller and smaller as our x becomes larger. However, our f of x function here can never equal 0. The only way this can equal 0 is if somehow in our numerator we can have the value 0. However, we have this constant here, 12. As a result, this function can never equal 0. So we know that as our x becomes larger, our y becomes smaller, and it never equals 0. So the graph of our second function will look something like this. So our x is as small as can be, but it will never equal 3. So we'll start somewhere here. Now as our x becomes larger, our y will become smaller. So it will look something like this. But it will never equal our y equals 0 here. So this will keep going on, and this will keep going in the almost parallel to the x-axis. So here we have the graph of our piecewise function. Just for an aside, let's look at the domain of our function. So we'll notice from here, x can equal any number less than or equal to 3. And on this function, we have that x can equal any number greater than 3. So in fact, we don't have any restrictions on x. So we have x such that x belongs to all real numbers. And again, we have that x equals 3 right here. And anything less than that, we know that x can be a number that satisfies our function. Over here with this function, it becomes infinitely close to 3. It doesn't equal 3, but that's okay because this function does equal 3. So in fact, our domain is x such that x belongs to all reals. I now want you to sketch the graph of the piecewise function in your question. This is how your final graph should look like.